Let's look at another rate of change problem. So here we're trying to find the rate of change in the elevation of the camera shown at 10 seconds after liftoff, where the rocket's position is given by s equals 50t squared, with s measured in feet and t measured in seconds. Let me move this so we can see the picture now. Here's the picture. We have a rocket lifting off and there's a camera following it. And so again, we're going to break this down into what we are given. Well, we need a rate that we're given. We are given s in terms of t. S equals 50t squared. And so if we take the derivative of this equation, ds dt, we get 100t. And I'm told that t is equal to 10. So ds dt would be 1,000. 100 times 10, or 1,000. So what are we given here? We're given ds dt equals 1,000, and our units are going to be feet per second when t equals 10. And then I need to identify my equation and what I need to find. Well, let's start with what I need to find. If I look back, what am I asked to find? I'm asked to find what? The rate of change in elevation of the camera. So I'm asked to find this theta. See in my picture, I'm asked to find d theta dt when t equals 10 seconds. And so because I have theta, the equation I need to use needs to involve both s and theta. So they gave me the equation. If I look in my picture right here, tangent of theta equals s over 2,000. Okay, so I have my everything mapped out. So I'm going to take my equation that I was given here, tangent of theta equals s over 2,000. And I'm going to take the derivative of both sides. So the derivative of tangent, remember that that's secant squared d theta dt. And then the 1 over 2,000, and then the derivative of s is just going to be ds dt. So what values do I know? I know what ds dt is, right? What am I trying? So before we do this, what am I trying to solve for? I'm trying to find d theta dt. So I need to find this. So let's go ahead and divide by secant squared. Secant squared theta. D theta dt. It's 1 over 2,000. And then it'll be cosine squared. 1 over secant squared is the same thing as 1 over cosine squared. All right, so now, remember I'm trying to find this. I know ds dt, but I don't know cosine of theta. So I'm going to need to go back up to my picture and figure out what cosine of theta is. So let me go down here. let's redraw our picture so it's a little bit easier for us to look at. Here's theta. This distance was 2,000. And then I had this distance s here. Well, we're given t equals 10, and there's a relationship between t and s. It's that s equals 50 t squared. So I can plug in t to find s. So I'm getting 5,000. That's what s is equal to. So in my picture now, I can swap out s, put 5,000 here. And then this missing side over here, it's the square root of the two sides squared, 200 or 2,000 squared plus 5,000 squared. And so now I can find cosine of theta. Cosine of theta is adjacent over hypotenuse. Adjacent is 2,000. The hypotenuse is 2,000 squared plus 5,000 squared. And now I know cosine theta, so I can go back to my d theta dt equation. It was 1 over 2,000 times 2,000 over the square root. It was cosine squared, so that's squared, times, well, I had ds dt. What was ds dt? It was 1,000. So from here, you're just going to simplify. This 2,000 in the bottom will cancel with one of them in the top. There's two of them, so it'll be, so I'm getting 2,000 times 1,000. And then this square, when I square a square root, the square root goes away. So it's 200, or 2,000 squared plus 5,000 squared. And so then you would put this in a calculator to simplify this fraction. It's going to be 2 over 29. Now, what are my units here? Remember, it's important that we have units. Theta is measured, it's an angle, it's measured in radians. So this is radians per. And what was t measured in? T was measured in seconds, so it's radians per second. And then this is my answer for this one.